Hello and welcome to the sixth section of our journey. In the previous section, we covered some master topics in the Go programming language. We covered concurrency, reflection, and some design patterns. In this section, we'll start by explaining the steps we need to follow in order to write unit tests in Go. Then we will test some code performance by doing benchmarking. And then we'll conclude by taking a deeper look into cross-platform compilation. So let's get started. We'll start by discussing unit testing in the Go programming language. In this video, we'll start by describing how to do unit testing in Go. We'll then apply the new knowledge to write some unit tests in order to examine the Hydra chat code. Then we will run our tests and see what happens. Go comes ready with a testing package, which represents our best means to design unit tests in Go. Please take a moment to look at the package page, which can be found at golang.org/pkg/testing. Writing unit tests in Go is easy. It consists of 4 simple steps. First, we create testing files by creating a new file, then appending _test.go at the end of its name. Go tools will identify this file to be exclusively for unit tests and will not build or execute it unless you require tests to be run. Second, we import the testing package inside our test file. We then write functions inside our testing files that will start with the word test and will take the test.t pointer as an argument. Those will be our unit testing functions. Finally, we will use the Go tool with the test command to run our tests. Let's have a look at the test file from a third-party library to get a feeling into how this looks like. We will explore the unit tests of the WebSocket library. This package exists in the golang.org folder, underneath the X folder, underneath the net folder, and then finally, of course, the WebSocket folder. If you look at the WebSocket folder, we'll find a file called websocket_test.go, which is where the unit tests are written. Note how the unit test file is appended by _test. That was the first step we discussed to create unit tests. Next, we can see here that the testing package was imported. Third, our main test functions start with test. Note that the T in test must be uppercase. This is so that this function becomes exportable and could be used with other packages. The test echo function tests sending an echo signal on a WebSocket. We notice here that we start by calling start server, which gets called only once, using once to do. Start server acts as an unexportable helper function, which we can use in our test file. Here, this helper function sets the HTTP handlers for the WebSocket, URL addresses, which are used for tests in this file. Now back to test echo, we first try to dial the server address which we need to reach. If that fails, we will use a function called fatal, which belongs to the argument that got passed to our test function. So as mentioned earlier, the arguments passed to our test function always have to be of type pointer to testing.t. which includes fatal. Fatal will effectively fail our tests, show an error, and then exits. Fatal must be called from the original Go routine of our function, and not from within a new Go routine. Now, if the test doesn't fail, we continue our code flow. So we need not to dive into what the rest of the code does, only that in case of errors, we call methods from the testing package, which allows us to report those errors. Error F is used in these cases so that we can print our errors with a desired string format. In some cases, we can call return after to exit our function and finish. In other cases, we can ignore calling return and just continues our code execution. The last step is to run unit tests. We do that by calling goTest from the WebSocket folder, which is a folder where our test files exist. This will scan the folder and will search, then run any _test files. So as we can see here, tests have passed on this package. In the testing package page, we'll find all the methods used in the previous test and some more. Please take a moment to have a look at those methods to understand what they do. Mostly, we can use fatal or the fail methods to fail a test, and the error methods could be used to print an error message in our test results. Awesome. Now it's time to write our own test from scratch. We will write some tests to examine our Hydra chat code. Let's start by navigating to the Hydra chat folder, and then we add a file called chat_test.go to honor the rule of appending our unit test files with _test.go. This file will be part of the Hydra chat package, since it will need direct access to functions and methods of this package. Next, we import a bunch of packages to use in our code. We'll see them used as we go. Note how the testing package has to be imported. So the run function in the HydraChat.go file, which we use to start our chat server, takes an argument, which is basically a string representing our connection. So we use it for listening to incoming messages. Now back to the chat_test.go file. Let's write our first test function. We will call it test run. As we covered earlier, it has to start with the word test, the function name that is, with a capital T. And it takes a testing.t pointer as an argument. And testing.t is a type that we have covered earlier, which we can use to call important functionality from the testing package. We will use different testing methods in our code and explain them as we go. So this function will connect to the chat system, then write some messages and read them back to test whether the system broadcasts the messages back to the listeners on the same chat room. So basically we're writing a message and reading it back from our chat room. Let's assume no one else is connected to the chat system port number at this point of time. We'll start by writing a Go routine where chat server is run on port 2300. And the reason why we use a different go routine here is because run here will be a blocking call, because this will listen to the chat server. Note that we used a method from the testing package called log. Log does not indicate failure by itself. However, it helps us log some important messages which will show up if the test fails at a later time. We then use t.error when there's an actual error, and then return to exit the go routine. Otherwise, we log another messages identifying that the Hydra chat server had started. We then will sleep for about 1 second to give the system some time to connect. Afterwards, we'll use the rand package to obtain the random number. So use rand.seed to obtain the random number, and we will give it the current time in nanoseconds as a seed. We'll then create a string called name, which we'll use as our chat name. It will be called anonymous, followed by a random number. We will then use a method called logf from the testing package to log a message indicating that the anonymous user is connecting to the chat system. Again, this message will only show up if the test fails, but it will give us an indicator of what worked before the failure happened. We will then use a popular net.dial function to connect to the chat system TCP server. So in here, we created the chat server and it's listening on port 2300. And in there, we created the chat client and it's also connecting to port 2300. Note that if run failed from the above go routine, which is what we use to start our chat server and chat room, then the net.dial call will fail as well, because there will be nothing to accept the TCP connection. And in this case, this error will be triggered, which is when we will use the fatal call to indicate that the test had failed with this error message, which would indicate that we could not connect to the Hydra chat system. So if we get to this point and the test haven't failed, we can use a log method from the testing package in order to indicate that a connection occurred to the chat system. We'll then add semicolon to the client chat name to include in the chat messages we're sending. So if you remember, when we created the Hydra chat system, the message formats that we expect would look something like this. So it will be name, then my chat message. Name here will be the client chat name that we use for our chat, and in our case it's anonymous, appended with a random number. And then this is where we add the semicolon. And now the next step is to write the chat message and send the whole string. Now we will defer closing our connection to the chat server for resource cleanup. And after that, we'll create a channel of type string called message channel. This channel will host the message we will send to the Hydra chat system. We'll see how we use it very shortly. Now we'll create a for loop which will send 10 random messages. Each one of those messages will be called random message with a random number attached. As we mentioned earlier, the message has to include the name of the sender attached with a semicolon. So for example, if the random number for the anonymous username is 4, our first random message will look something like this. So it will be anonymous 4, semicolon, then random message space 1. We'll use fmt.fprintf in order to write the message appended with an end character to the connection stream. And this is the client connection stream, which is the representation of the TCP channel leading to the chat server. Now, if errors are observed, we'll use the t.error method, which will log the error and fail the test, and then we'll call return. We can also use .fatal, which will do something similar. So the above code is equivalent to calling t.fatal with an error message. Now, if we don't encounter an error and reach this point of the code, we pass a message that we created to the message channel. We will then use the value stored in message channel to compare the values sent by the client with the values received by the server. And we'll see now how to do that. We will write a new Go routine which will handle reading messages via the chat connection channel. We'll use the buff.io scanner to scan incoming messages. Now, incoming messages from the chat server that we receive here on our client channel will represent the chat messages that our server had received. So by comparing messages that are received from the connection with messages that were sent to the connection, we can establish whether our chat server is working correctly. Now in our new Go routine, we'll use scanner.scan to receive incoming messages, and once we receive a message, we'll store it in a variable called receiveMessage, and then we'll retrieve the value stored in the message channel. If you remember, the value stored in the message channel should be whatever the last value sent to the chat server. Now the next thing to do is to use string.compare to compare the received messages against the sent message. And if they don't match, then we register an error, because we now know that the chat system is not properly propagating the messages that we have sent. However, we will not call return here, because we still want to keep running. Now let's run go test from the Hydra chat folder, where our chat_test.go lives. And we'll see here that the test had passed. Perfect. So every message that we have sent was received back from the chat server. Now how about we make a change to our code to see a test fails and inspect how the output looks like. So in our case, let's change the port number that the client is trying to connect to 2000, where no chat server is listening. So by doing this, this call should fail, and it should evoke the t.fatal call here. So now back to the Hydra chat folder. If we run go test, we see here that the tests have failed. We can see here that the last error was a t.fatal error message that we have logged. We can also see here that all the t.logs that we have used in our code up to this point now show up in our log trace. Note that those messages, even though they're not called errors, because they belong to the testing package, they would only show if an error ended up happening at the end. Now, what if we're running multiple tests? In this case, we need to ensure we start the chat server only once. For this, we will use sync.once type. So we'll create a variable called once, and then we'll create a function called chat server function, which is basically a closure. So it will take testing.t as an argument as usual. However, it will return a function with the signature that sync.once accepts. And in order to achieve this combination, we have to use a closure. So we return the function with sync.once supported signature. But since it's returned within the chat server func, which is a parent function, it has access to testing.t methods. Now in test run, we can use our newly created chat server func, which was a closure, in order to initialize a chat server. By using once.do, this function will only be called once. And because we use the function closer here, once.do would accept this function. And finally, we run it in a Go routine so that it does not block the rest of our code. So this code will only run once. Now let's write a new test. What if we want to write a simple test to just check if we can connect to the chat server? So first, we will use the function closure that we've created to initialize the chat server. And again, because we use once.do, if this function already ran, it will not run again. This will help us ensure that if another test had already started the chat server, then we don't have to do it again. We will then sleep for 1 second, assuming that if this run, we can give it a second to properly initialize. Next, we attempt a simple connection to the chat server. If it doesn't succeed, we issue a fatal error, and then we close our connection to clean up resources. The testing package provides a function called short to identify if a flag called short is requested by the user. So sometimes we can pass a flag called short in order to skip or shorten some tests. There is also a method called skip, which is used to skip tests. We'll see how we can use this feature in our code. So let's assume we want to skip the long test run if the user passes short flag. Then in this case, we can just call testing.short to check if the short flag was called. And then if the short flag was invoked, we can call t.skip, which will skip our test with a message. The short flag is passed by adding a -short after the go test command, as shown here. So if I run this, we see here that the big test did not run. We can tell because we don't see the chat traffic anymore. So if we compare this result with when we only call go test, we see here the chat traffic, which means that the long test had run. In this video, we took a practical dive into how to do testing in the Go language.